So we are live now. Um,
1 minute, let me check. Yes, Ishita, you can start.
okay. So how many people have joined us yet? Because that's not visible to me right now. Okay.
There is only one people up now. Let me share it and go.
So we should start
Ishita,
at
we can start.
6:25.
We can start now. They can watch recording.
Okay, sure. Uh, so, hello everyone, good evening. My name is Ishita Soni and I'm your host for the evening. Our speaker here is Miss Yashika Kokar ma'am. She is an ST at Morgan Stanley and she has been an Amazon ML Summer School 24 and a scholar trainee at Catalyst India. So, ma'am will be starting the session for the week 2 of our Amazon ML Summer Cohort. Over to you, ma'am. Thanks for coming and giving us your time.
Yeah, thank you, Ishita. Hi, everyone. So great to have you all here. Let me start with the quick show of hands. Ishita, can we see the audience here? Like, I can see if I'll be able to see the number of people joining over here.
We can see at the top we have 8 people with us right now, and more are joining.
Okay, so will we be able to see the reactions or something by them? Like, will I be able to know
Ma'am,
if they are
you can see the comments
okay? All
on the
right.
right hand side.
Okay. Yeah. So, yeah, thank you, Ishita. Hello, everyone. My name is Yashika. Currently, as Ishita said, I'm interning at Morgan Stanley, and now I'm a full-time employee over there. So let's begin with our today's session. So we'll having a session based on linear regression, logistic regression, and even we'll be uh, seeing how the models matrices are there and how the models are evaluated based on different criteria and which model to be chosen as per the situation and while you're making your projects. So yeah, let's begin with that. So I'll be sharing my screen with you all and the ppt over there. Please let me know if it is visible. Give me a second. Ishita, I'm not able to share the screen.
Uh,
Ishita, you can add to stage the screen shared by ma'am.
okay. I can't yet see the screen.
Yeah, I'm not able to share even. It's not showing the share option for me. Like it's showing the share option, but
Ma'am,
I think it's not visible to you all.
Okay. If you can share the PPT with me, then I'll share it because,
Okay.
or I'll try to give
ma'am,
you access.
I will share the PPT to Ishita, then she can share it.
Okay. All right.
Ishita, I have shared the PPT with you.
If you can just give me the access to share the screen, I would be able to.
Ishita, you are muted.
Okay. Um,
Yes,
Yeah,
screen is.
are we good to start with?
Yes, ma'am. Ma'am, your camera is off.
Yeah, one second, let me check. Am I visible now?
No, ma'am.
not yet.
Hey, hello Ishita, hello Lakshmi, hello everyone. Hello Shika. Maybe you can like switch off and
Um,
switch on your camera. I guess then you will be visible.
Yeah, one second.
Yeah, that would be great.
Yeah, now am I?
Yeah, perfectly. Now you're perfectly visible. It's good to go. Now we can start.
Yeah. So, yeah, firstly, we'll be discussing today about the linear and logistic regression and also the evaluation matrices of several models. So, like it's a basic and yet very important concept in machine learning. So, I would love to know how many of you are aware about it or are willing to learn about it. Can I see a raise of hands?
Sure. It's more like a live stream, so we can only see comments. So we can move forward with it.
Okay.
Cool. In the
Okay.
AMA session or maybe in the next session, I guess we'll be having two session, Lakshmi, or one session.
Okay. Okay.
We have
Yeah.
one doubt
So,
session.
Okay, in
sure.
doubt session, we can have it on Google Meet, Jessica. Then we can interact.
Okay. Sure. So, yeah, both linear and logistic regression are a part of supervised learning. That means when we train a model using input and output, so we are the one defining the input as well and the output as well. So, that's called as labeled data in machine learning terms. Think of it like practicing a maths problem where solution is already given to you guys. You learn by comparing your method to the correct answer. So, that's more like a supervised learning concept. We use supervised learning to predict values or categories, and that's exact we'll be exploring today. Can we move to please next slide?
Ishita, you mute.
I hope it's visible.
No, it's not visible yet.
No,
I'm
it's
able
not
to see
visible.
the first slide itself.
Okay.
Yeah.
Yeah, you can share the entire screen or maybe that specific. That would be good.
Yes, I think it's visible now.
Wonderful. Yeah.
I still can't see.
Next page.
It's visible, like a black screen is visible to me with the lines, not the PPT screen.
Okay, PPT. I guess the PPT is visible to us. I can see
Yes, it
it.
is visible.
But yeah, it's not yet visible to me.
Okay. It will take just a minute. So sorry.
It's okay.
No issues. Maybe the network issues would be there. It's totally okay.
Okay.
Is it visible, Ishika, to you now?
Not really. Okay, I can do one thing. Like I'll keep the PPT for my context, and if it's visible to you all, then it's fine.
Okay. Otherwise, if you want, I can share too from my side. Maybe then it's good to go. Then it would be visible to you, I guess. Shall we do
Yeah,
that? In the
okay.
meantime, you can go. Lakshmi, you can send me the PPT. Wonderful. In the meantime, Yoshika, can you share like how's your day at Morgan Stanley, and is AMSS program is like how many doors of opportunities AMSS programs open, especially for the people who want to delve into machine learning and all. Is it really valuable? And what after that does Amazon give any other opportunities?
Yeah, so as per my experience, so for the selection process for Amazon ML Summer School, you have to go through like a online assessment containing of aptitude, which includes like machine learning questions or several aptitude questions, especially based on machine learning, we can say. And people sometimes miss out the very basic concepts, which they are like not giving much priority to. But I would say learning from basic to advanced is something like we should always remember the basics of everything. And I think by taking that step you can crack that out. For me it was like first started with the aptitude and machine learning questions, followed by coding section also. So DSA also plays an important part here, as we get to see around like easy to medium or sometimes hard also questions in DSA, especially in machine Amazon ML Summer School. And yeah, I think out of like all over India, only 3,000 people get shortlisted based on the results and their performance in Amazon ML Summer School. And yeah, after that, Amazon Science, you get a mail by Amazon Science giving offer letter to you, like a completion letter, not offer letter, letter of appreciation, I would say, for completing the ML Summer School sessions, which you get to attend by their experienced and very professional SMEs. And yeah, after that, there are openings in like machine learning, like I would say research analyst or data scientists. So yeah, you get to have opportunity to sit in that as well.
Wonderful. So overall, it's like a good opportunity for everyone. Ishita, I have shared my screen. Are you able to see it?
Yeah,
My screen.
it's perfectly visible. Yeah.
Okay.
Okay.
Yeah. Is it visible?
No, it's not visible now. It was visible before.
Okay, you can.
We can continue like that. It doesn't matter.
No, no. Ishita, can you like bring the previous page? Previous.
Now is it visible?
Not really.
It
I
is
again.
visible.
I guess there is some network issues on
No,
StreamYard.
before it was visible to me when you have shown me like not in the present mode. So it was
Oh,
visible in that way.
uh, is it
Okay.
just
Okay.
for you or for everyone right now?
It is visible
Is
in the live
I
stream.
can move again.
Okay, Yashika, what we can do if you're getting problem, we can shift it on Google Meeting. Maybe as for short notice, a few very few people would join, but we can record the session and then upload it on YouTube. What do you say? If
Yeah,
this
it
is
would
causing
work.
problem.
Yeah, it would work for me.
Okay, so we can shift it to Google Meet, right?
Yeah, sure.
Okay, wonderful. I'll create a Google
Or
meeting
like,
and
if you want, like, you can give me the access, then I can also share my PPT. I don't mind that.
yeah, everyone has the access. You can obviously share.
I wasn't able to do so before. Okay, just let me try for one time, and if it will not work, then we can shift to Google Meet.
Cool.
Okay.
And I'm so sorry, everyone, for the inconvenience. And maybe this is a good opportunity for you. You can join the Google meeting and interact live. That is also a good thing. So maybe Shika, you can try once, and then we can see what works best for us.
Yeah, is it visible now?
Okay, Shita, can you like add Vanshika's PPT to stage? Just be
Is my screen visible to you?
Yeah.
Yeah, so are we good to start with now?
Yeah.
One second. Yeah, so we were discussing about the linear regression. So, yeah, what does linear regression mean? So it's a way to predict a continuous numbers using the past data, I would say. So in linear regression, we have like relation between variables. Some are dependent variables, like one is a dependent variable and the others are independent variables. For example, if you want to predict houses, estimate like salary based on experience, or like some of the examples are like forecasting next month sales, or how much you can score in your exams by calculating how many hours you have studied. So these are some of the basic examples which our linear regression models tell us in predicting, like it predicts them. So basically there are two type of linear regression. One is called as simple linear regression. In this we have just one input variable, so dependent variable is one every time in the linear regression, and independent variable is also one in simple linear regression. And also we have multiple linear regression where we tend to see so many independent variables, because predicting something can be influenced by multiple things, not just one thing, right? So we tend to see multiple linear regression in that case, where we can have two or more, I would say, independent variables. So yeah, this is what linear regression talks about. Okay, so here we have a numerical example. If we want to predict a house based on area, suppose we have this data set, area, price is mentioned over here. So how are we able to, like, how will we able to predict it? How will we able to predict the price? So here price is the dependent variable. So price is dependent on which factor? In this case, it is dependent on just area. Area is an independent factor. Like area can be anywhere, right? So it is an independent variable. And we can have multiple variables like this, like the size, area I've already mentioned, location of the house, I would say, number of rooms it can have. So these all are independent variables which can be used in predicting the price of a house. So yeah, using linear regression, we fit a line. We have a equation in linear regression. It is y equals to mx plus c. In basic maths also we get tend to study it. So y is the dependent variable over here, which is depending on like mx plus c. You can see in next slide. Yeah. So beta not equals to beta 1 plus x. So here x is the independent variable, and beta 1 is the slope over here, and beta naught is the intercept. Like in basic maths, we tend to see this equation. So similarly, in linear regression also we have this. So in this numerical, we can see price equals to 0.03 into area plus 20. Now if we want to predict the price of a house whose area is 1800 square feet, so we can just simply put the area and get to know that how much price it would hold. And like if we increase the from 1800, I would say I don't want the area to be 1800, I want to be like 500 square feet. So this would simply manage the price accordingly. So this is the power of slope, I would say. So slope basically um, is very very essential in determining the price over here in this example especially. Yeah, so this equation I've already discussed with you. It's simple maths equation, and we can see the relation of independent and dependent variable in this. It is like this equation is basically for simple linear regression, as we just have x as a independent variable over here, and not like so many independent variables over here like x1. This equation for, I would say, multiple linear regression, it can be beta 1 x1 plus beta 2 x2, like that way. So there can be a series of independent variables which help us in determining linear regression, and we get to see the outcome of the model based on this. Yeah, so this is the visualization how the linear regression looks like. So this is a scatter plot where we are seeing this red line is regression line having several data points over here. So linear regression is basically a technique used to find out the best fit through data points. So if more data points are near a line, then I would say it would be like line is the we have two things, okay, actual outcome and the predicted outcome, right? So data points are the actual original things which we are having, and the regression line is the like how we tend to predict it, how much linear it is in terms of performance, I would say. So we draw a best fit line that minimize the distance between line and each data point. This line is what we want to learn in linear regression. Yeah. Another most important thing in linear regression is the gradient descent. So gradient descent is basically an optimization algorithm. Okay, so now how do we find the best fit line using the gradient descent itself? We use optimization technique, and yeah, like in every scenario, we cannot have the best fit or the best curve, I would say. So we tend to have some optimization techniques to, take out your data points more closer to the line, so it can have a better impact on that. Think of an example like you want to maybe roll a ball down the hill. The ball tries to find out the lowest point, right? Like if there is a slope and the ball is like you have thrown a ball simply down a hill, so it will reach the lowest most point, so that means the least error. So that's what the gradient descent also do. It adjusts the slope, and it tries to have like the minimum error, and it tries to give you a more linear curve to have the best result of linear regression, I would say. At each step it adjusts the slope intercept to minimize the cost, or like we can say errors also in prediction. Yeah, so
Ma'am,
yeah.
Ruchika is asking in this regression which fitting are we using, overfitting or underfitting?
uh like no, like overfitting and underfitting both are not used over here. We'll discuss it in a bias and variance concept further. So overfitting and underfitting are two features that are based on the two most important concepts, bias and variance. So we'll cover it later in the next slide. Firstly, for the gradient descent, it's basically optimization technique. Like you have a data model or data set, I would say, and you are seeing like how much linear your curve is going. That's where you tend to take out your data points more closer to line. Obviously they cannot come more closer to line itself, so you have to adjust the line in such a way. That's what we are discussing, like the slope and the intercept of the line. You can take the random values or I would say the values to adjust to like to fit to the best fitting of the curve. So that's when we use this. Yeah, so repeat. Okay, fine. So, okay. The most important thing, functions in linear regressions. So like to measure the errors, I would say loss function here is like just defining the errors, I would say, in linear regression. Like in every machine learning model you will tend to see some of the errors. Like no model can be perfect, and if it is ideally very perfect, like something you are missing out, maybe a pattern or maybe something. So yeah, we tend to see loss function, and we calculate like how much error, how much like our predictions are, the model which the predicted values which the model gives, how much it is varying from the actual values which we must get. So that's when That's where we see the loss functions over there. So basically there are two types of loss functions. One is mean squared error and the other one is mean absolute error. So yeah, bigger errors like hurt more, I would say. So that's where the squared errors come in. When the errors are squared, it basically gives you more like do not gives you like for the large data set, or I would say for the very very the dataset which contain outliers, their MSE should not be used, because outliers, okay, so first of all, what is outlier? Outlier is basically like, think of a situation where you have a data set like in points, like point 1, point 2, point 3. Some of the numerical values are there in such a way, and the one value is like 9. So 9 is like quite odd, I would say. So that's what the outlier mean here. Something which is not relating with the data set, it's more like off way or off track, I would say. So that's where outliers come in. So if we are dealing with the data set which contains a lot of noise and outliers, there we do not use the mean squared errors. As the name suggests, mean squared means we are taking out the mean of the errors by, firstly by squaring them, and then we are taking the mean of the errors to calculate the loss functions in such a way for our machine learning model. And for the mean absolute error, what we do, we take the absolute values, like negatives and positives are like this is how the absolute function works. So yeah, we are not treating like the data set which have not do not have outliers, or like which is a balanced data set, I would say. There we tend to see a more use cases of mean absolute error, because it's less sensitive to outliers. And yeah, for the data set which has a few extreme values or outliers, we prefer using calculating the mean absolute error, because in that case mean squared error will not give you a correct answer, or may not give you a perfect result, I would say. Yeah, so basically our linear regression gives us a certain concepts. It covers certain concepts like linearity, which is the first most concept, I would say. It teaches us that model should be linear, and how much like the linear relationship occurs between the dependent variables and the independent variables. And obviously independence, because we can have multiple independent variables over there. And homoscedasticity, and obviously the normality should be there between the data points to have a good outcome, I would say. Yeah. So yeah, when we talk about the linear regression statement, we said that we have a equation y equals to mx plus c, or y equals to beta 1 x plus beta naught. So beta 1, which is the slope, is directly proportional to the dependent variable. So more the slope is, more the value of dependent variable would be. Like it's a direct relation, so we tend to see it over here. Okay, yeah, so somebody was asking about underfitting, overfitting. We'll cover it here. In bias and variance, I would say. So bias and variance, imagine like you are shooting arrows and every arrow hit far from the bullseye. Like every arrow is hitting far for every arrow. Okay, so but all are hitting on the same spot. That's the high bias. Means like your aim is consistently off, you are consistently not meeting the required state, I would say. In machine learning, this means the model is too simple, it misses some patterns or it underfits, like every time it is hitting a point which is not even near the targeted value. So that's when we say we might the model might be missing some basic patterns. And yeah, that's not an efficient model, I would say, because we anyway, like we train a model what to achieve, like to achieve a higher accuracy and good results, right? So in that case we say it's a highly biased model, and obviously it underfits, it do not even comes nearby the targeted, like the actual like the values which we want. And variance, now imagine like all the arrows all over the place, some hit some miss, and some like fly off the board. That's the high variance. So like you are not very consistent about one situation, you are meeting multiple of them. You are uh, I would say, like you are not able to even say about a targeted state, like which one will you refer for the to see like which one is more closer to targeted state, because every action which you are taking is different in their own terms. So that's where we say the model is highly variant, and the model is too sensitive, reacting even to noise, so it overfits. That's where we say it is called overfitting. So what do we want basically? We want a balance between them, just enough complexity to learn the pattern, but like not so much that it memorizes every bump. Okay, so we need to have a balanced data and balanced data point, so to avoid the highly biased model and the even the highly variant model, I would say. So to take a balance between them, we'll study bias variance trade-off in the coming slides. Okay, so yeah, the another type of regression model which we are going to cover today is logistic regression. Logistic regression is basically for predicting categories, not just the numbers or the continuous predictions which I covered in linear regression. So it's not just about that, it's even more about that. It's trying to cover the categories and predict the categories of different, I would say, examples. Like we want to see if the transaction is fraud or not, we want to see if the email is spam or not, or will it rain tomorrow or not. So it's more about yes or no, so it's more about the probability. So in logistic regression we tend to see how probable the situation is and how much more likely it is towards a non-existing state or it's towards existing state. So here we see that logistic regression uses the sigmoid function to turn predictions into probabilities. Between 0 and 1 we can say the results may lie. And yeah, so like if we have a data set, uh, I would say, like we are talking about the email is spam or not. So we have a class, right? Binary class means yes or no, right? Spam or not spam. So in that case, we see like the data sets have 50% of the emails as spam and 50% of the emails as not spam. So that is where we call the data set as balanced data set, because both the opportunities are equally available for the model to learn and to predict the outcomes. So there we see that there is a balance between both of them. And for the I would say if the class has 70% of fraud, like fraud transactions, and 30% of non-fraud transactions, so there it's like less likely for a model to be accurate because it is learning more about like the fraud transactions. So it would be quite less, I would say, accurate or efficient, where we tend to face like some non-fraud scenarios. So that differs in such a way. Okay, we see the logistic regression equation over here. It's a probability. So P here denotes the probability. And if the probability is like greater than zero point 0.5, we assign the class 1, else class 0, which means like as I've told earlier, if the results are more than 50%, if we are giving the data set to a model saying have a balanced data set, okay, 50% emails are spam and 50% are not spam, right? So if we tend to see the outcome as one, like we divide the data set in following like test data set, train data set, right? So we are training based on a balanced data set and we are testing. Okay, so I'm giving for the testing part, I'm just giving 70% as fraud email, like spam emails, and 30% as not spam emails. So if it turns out to be almost towards like more like the probability turns out to be 0 0.7, and if I'm predicting in case of not spam emails, like the category towards 70%, the side towards 70%, then I would say okay, outcome, the class is finally categorized as the emails are more likely to be spam. So we need to take care of that in such cases. Yeah. So this is the sigmoid curve, or I would say sigmoid function, which we use in logistic regression. And yeah, it clearly shows that the probability is 1 to 0. That's why we have a curve in such a way from 1 to 0. And also between the like 0 to 1 we can have a varying values, which can tell us to define like which if we want to uh, set the class as towards the class 1 or class 2, maybe like the situation which we are working on, it depends on like that. So yeah. So yeah, typically like point 0.5 for binary classification, we have the threshold. So this threshold can be changed depending on the use case. Example, like in medical cases, you may want a lower threshold to catch more positives. Then you can have to see accordingly. So basically, you have to see the categorization, what you are testing. So, and you have to see that the data set which you are giving to the model to train, it should be a balanced data set, so that you can have a better outcomes while testing the data set. Yeah. So we will cover about model evaluation matrices. So it's a very very essential part. You have trained the model, you have tested the model. Now you want to see how much it is effective as per your use case, or how much it is better performing, and what are the missing fields, like it is going under fitting, overfitting, or the extra features you have given, something like that. So you have to see the models, evaluation matrices as well. So there are multiple ways to evaluate the model. Okay. So yeah, firstly we'll discuss about bias variance trade-off. So as I mentioned, bias variance uh, is a like situation where we have to have a balance amongst bias and variance. uh, like the model is not so scattered, I would say. So low bias, high variance, or low in the curve, you can also see like on the leftmost part, I would say this is the uh, like low bias and high variance, and on the rightmost part it would be like the bias variance trade-off is adjusting. Like this yellow line is showing the bias variance trade-off, so this blue line is showing you bias, and this black line is showing you the variance. So somewhere between them the trade-off is existing, because see, the bias and variance are not at all meeting, not at all crossing over each other, right? So you need to have a value that must be somewhere near, I would say, towards bias or variance. So that's why, that's when you need to have a balance between both of them. So it's essential in that part, I would say. And yeah, so bias variance, yeah, we can cover. Okay, so let's talk about the model matrices. So it's accuracy. First of all, accuracy comes in picture. So here we'll be seeing four important terms: true positive, true negative, false positive, and false negative. Okay, so I'll give you a situation where think like some emails are fraud, some emails are spam, and some emails are not spam. And I am saying the one email which I want to test is a spam email. So if the model says, means I know the mail is spam, but the my model also predicts it correctly. It also says yes, the email is spam. That means the model is giving you a positive value, and obviously you like have a positive value, and the model is also giving you a true value in that case. So that's when we see the case of true positive. Positive is the situation, and the model outcome is also true. So that is called as true positive. And imagine like the mail which I am testing is not a spam email, it's a normal mail, and my model says yes, true, like it's a not spam email. True negative, like I say, the model means I say the email is not spam, and the model says yes, it is not spam. So like it is contradicting the situation. I say the email is spam and the model says it is not spam. So that's where we see true negative comes in. For the false positive, I would say like positive, like situation is positive and model says no, this is not the case, so model is wrong in that case. So that way, that's when false positive comes into picture. And for the false negative, the different thing, like I say something is negative, something is not spam, and model also says like it's a false, like it's a not spam thing. So that's where it predicts correctly. So that's the situation of false negative. So these are the four important terms which we also see in confusion metrics also. We'll cover it in the next slide. And yeah, so basically accuracy, here we see, now we can discuss about the accuracy. So like we tend to see in accuracy how many predictions were correct out of total predictions. Like you made certain predictions, and but how many of them were accurate. So that's where the term accuracy comes in. And so yeah, but in imbalanced data sets which we see, it can be misleading. Like data sets are, the data points are very varying, and you can have 95% of non-fraud data for an example, and predict non-fraud every time. So your model says yeah, the data is non-fraud every time. So 95% accuracy, which is useless because it is not able to predict the 5% fraud data. Okay, so for that case, it is not a relevant model to judge the fraud or non-fraud in that case. So you need to have a balanced data first of all, like you need to remove the outliers or before training it. So you need to look upon these small things to have better outcomes and better results. Okay, so now we cover about F1 score. So yeah, F1 score formula is here, like precision 2 into precision into recall divided by precision plus recall. So we'll see what is, like I would say, precision over here, and what is, like, wait, yeah. So we'll see the precision and recall over here. Precision like measures the accuracy of positive predictions, while recall measures the ability to find all the actual positives. So precision and recall are two important things. We need to measure the accuracy of like predictions which were positive, like which were true. So we calculate precisions for them, and for the recall part, we see like all the positive scenarios we see out of the total scenarios. So this is like F1 score is the best. Like if your model have a best F1 score, then it will have a better accuracy in terms of it is working fine, and it is uh, you know m- uh, acting as per your use case. So that's where we need to have like F1 score. But obviously to calculate anything like F1 score or any accuracy thing, you must have to have a balanced data set at the very first point. So yeah. Okay, so now we'll be discussing about the confusion metrics. As I have discussed earlier, we have four important things over here: true positive, true negative, false positive, and false negative. So I think I have given a clear picture of this. And yeah, so this is something like predicted positive, predicted negative comes above the, like above the, like, it's a column part, and for the rows part we have actual positive and actual negative. So true positive and true negative, like you have to map the matrices in such a term to tend to see actual positive, predicted positive, like actually the thing was positive and your model also predicted it as positive, then it's true positive. Actually the thing is positive but your model predicted it's negative, it's false negative. Okay, imagine like if a person or a patient has some disease and the model says no, it is negative, the person do not has a disease, then it can cause a really bad impact, or I would say not the correct results for the patient. So that's where you tend to keep an eye on if the model is predicting correctly or not. For the false positive, imagine if the actually the patient result was negative and model say no, you are positive, and the doctor immediately says okay, let's start medicine of this person, then obviously it's not good in that case also. So here also the model is a like not a good model. So false positive is also like the like I would say not a good part for the model to be there. So we have to consider all these scenarios to see if the model is you know predicting rightly or not. So yeah, we tend to see all these yes and no scenarios to see if the model how much like it is better at performance and not, and how much efficiently it is working. So we need to consider all these scenarios. Yeah, so for the balanced data set, when means like I've told you, for the data points which are balanced like 50% and 50% ratio maybe, or 40/60, that's also quite balanced, right? So in that case you tend to see accuracy, like when you measure accuracy it's better, because like if you want to see like how many accurate cases were there out of total cases, so that's what we talked about accuracy. And for the F1 score, I would say you can use imbalanced data as well, because it deals with both like precision also and recall also. So it measures like properly how much your model is best at performance and how much it is not. And for any detailed analysis like of the error anything, then you must have the knowledge of evaluating the confusion matrices, considering all the cases of true positive, true negative, false positive and false negative. So it is especially in interviews, I would say it is really asked, because people are very very confused for true positive like confusion matrices elements. So you must know about it properly, like you must know how to define it with an example. It would be a better thing when you are especially answering something in interview also. Then for that, from that perspective also you need to know about that. Yeah, so for the summary part, I would say linear regression. Basically, it was a prediction of numbers in a continuous format we see. Uh, like it predicts numbers, or it would give you a best fit for the curve, right? For the logistic regression, I would say it predicts categories. If you want to categorize data based on the probability, if it is exceeding the point 0.5 threshold, or if it is less than that, and how can you classify it is belonging to uh, which particular class. So based on that, logistic regression works for us. And for the evaluation matrices, you definitely need it after model training, model testing. You definitely need to have a model evaluation to see how much your model is performing, like how much better it is at performance. And yeah, bias variance trade-off is also a very key important thing, which help you design models that generalize well, that you tend to see if your model is not too much biased and it's not too much variant also. So both of the things can harm the outcomes, so you need to definitely have a balance between them. So that's what trade-off stands for, and it's also one of the most important thing to be asked in interviews, like bias and bias variance trade-off. So yeah, this is also an important concept. Yeah, so thank you so much for hearing out and being an amazing audience. That's all for today, and we have some references you can refer to it. Yeah.
I think we can take up the questions now. We have a couple in the chat. Um,
Yeah,
can
just
you
give me
see
a minute.
okay.
Wait. No, it's not. It's like it's showing private chat for me and not the.
You can shift to comments.
I am displaying them on the screen right now. Like the first question is by Rutika Kengal. What does the output of logistic regression represent?
Okay, so logistic regression basically talks about, I've discussed, like it basically talks about the probability, right? So imagine like you are training a model based on some data points, and you say Like I've also mentioned with an example, if the emails are 50% spam and 50% not spam, and you are predicting, you're giving it a class to your testing model, and you are predicting for the emails which are not spam. So if it like guesses it in the form of like, okay, 0.7%, 70% part of it is uh, spam and 30% of it is not spam, so that's where the probability comes in. So major part is spam, so you will categorize that class to be as spam. So yeah, in the form of probability you tend to see the results of logistic regression.
Another one we have by Anshika. What is a good combination of bias and variance, or it depends on model?
Okay, so first of all, like you have to see, you are not okay. So while training a model, what's the essential steps which we think of? We think of training a model based on certain features, or I would say independent variables, as we have covered in example of like house prediction. So you must be capable enough of thinking, or while training your model, you must be attentive enough. If you are giving the right features while training your model, maybe like okay, you are saying I want to predict a house price based on like how many, I would say, beds it have. So it makes no sense. Like it's an irrelevant feature, or it's an irrelevant independent variable which you are giving to it. So that model will not be a good model, and the extra features will lead to the overfitting, and hence we will have like a biased model, and like more variant model where the features are not even matching and they are so widely variant with each other. So in that case, that model will not perform at its good. So based on certain scenarios, you need to see when to have like what features while training it. And yeah, I hope it helps you.
So Rutika has another question for you, ma'am. What is the key difference between linear and logistic regression? If we haven't already covered it.
Okay, so as I mentioned, linear regression basically, as the name suggests, it gives you a linear fit or the linear curve between the data points and what your model is predicting. So that line, that curve which we plot, it's linear in the ideal case. But when you will see, when you will train model, like no model is ideal or no model is perfect, I would say. Sorry. In that case, you will not have a linear line every time, right? So yes. So said, gradient descent also helps you to make the line, it tries to make the line more linear and minimize errors and all that stuff. So linear regression basically deals with the numerical part of the data set, I would say, like numerical data set. When you have, then you can see the use of linear regression. But for the logistic regression, if you want to categorize something into various classes, example, you want to say, like you are giving your model a picture of an apple, and you are giving it two options, if it is a banana or an apple. So you want to categorize it, you want to tell the category of that particular fruit. In that case, I would say logistic regression comes in, because the probability would be 1 for the apple option and a 0 for the banana options, because you are training your model based on certain features, like okay, if it is an apple, it should be red in color, it should be round in shape maybe, or further more features you can give. And also, like for the banana part, you will give like okay, it should be yellow in color, it should not be circular, it should be more longer. So yeah, like that way, you can say logistic regression gives you outcomes based on like distinguishing amongst classes. So that's where we see logistic regression. Logistic regression do not works on the numerical data set. It's basically invented or designed by machine learning. Like this algorithm basically is designed for categorizing things, if it is yes or no. So mostly about probability. Yeah.
Thank you, ma'am, for answering the questions. We have a few more minutes left. If
Yeah.
anyone wants to ask any question, please ask it in the chat.
Yeah, I can see in chat. Anshika has also asked underfitting and overfitting. So yeah, Anshika, uh, imagine like you are training a model, okay, and you are giving it a ball, or like a image of an ball which is red in color, and also image of an apple. So you are giving features like, if it is a ball it should be red, if it is an apple it should be red, because both will be red, right? You are saying if it is a ball it should be spherical, if it is an apple it should be spherical. Like only these two features you are giving to determine the outcome. Then it, your model will definitely go under underfitting, because it will not be able to predict the correct output, because both will be true in both the cases, right? And you will not be able to say if the object is ball or an apple. So that's where underfitting comes in, where we are not giving enough features to our model while training it, and it leads to misguised results and not the correct results. And for the overfitting part, we say we are giving the model extra features, like irrelevant features which are of no usage, and which will just like the which will only like confuse the model, and definitely it will not be able to guess the right outcome in that case as well. So we need to balance underfitting and overfitting, and we must have a better fit for it. So try giving the relevant features and see the like I would say linear regression was basically talking about that. I have said slope and independent variable and dependent variable. So slope basically talks about how much correlation both the things have, how much your independent variable is related to the dependent variable in predicting its outcome. So yeah, in that case you have to wisely pick up the features while training your model, and hence you will not undergo overfitting and overfitting. Yeah.
We have another question by Sharanya. Are classification models also logistic regression models?
Yeah, so logistic regression was basically for the classification. Like classification has multiple categories: binary classification, multi-class classification. So logistic regression is a part of defining it into a particular class. So it is a sub part of classification model, I would say. I hope it answers your question.
So I don't think we have any more questions for now. And ma'am has answered your queries and your questions really nicely. So thank you, ma'am, for giving us your time again. Thank you, everyone, for attending and staying with us and asking your questions. So I think we have come to an end for this session, and we'll see you in the next one. Thank you
Yeah.
once again, Yashika, ma'am.
Thank you all of you for being such a good
And thank you,
audience.
Vijay Lakshmi, for coordinating.
Yeah. Thank you all.
Thank you, Ishita, and thank you, ma'am, for coming in this session.
Okay. So I'll end the stream now.
Okay.
Bye, everyone.